Howdy. Howdy there. Thanks for joining me for a math video lesson on dot product of vectors. There it is. There's the dot symbol. That is the symbol for dot product. Looks just like multiplication. Don't confuse yourself, or don't get confused. So because dot product is slightly cryptic and a little bit abstract when we first study it, I'd like to share with you some of the application of dot product. So the first one is finding out if two vectors are orthogonal. Or for our sake, just two vectors that meet at 90 degrees. The next one is calculating the angle in between two vectors. Okay, that's very mathy. A little bit more applied, but still mathy, is calculating a projection from one vector onto another vector. Then we can take the idea of projection and calculate effective force. Ooh, that's when things start to get a little bit challenging, but very interesting. So hold tight. We're just going to focus on the orthogonal piece today and angle between two vectors. And then projection and effective force are in another video. So let's spend a few minutes just identifying what the dot product really is, how you calculate it, and its various properties. So first things first, for two vectors, u and v, the dot product can be described as this. U dot v, that's exactly how we'll say it, u dot v is u1 times v1 plus u2 times, I won't even write the symbol, u2 times v2. So notice we're just multiplying the first component of each vector and adding it to the second component of each vector. And we'll get into how that actually applies to what we're doing as far as projections a little bit later, but for now we're just getting familiar with the properties. So that's the definition of the dot product. Okay, now let's just take a peek at some of the actual properties. So the very first property is the fact that u dot v is the same as v dot u. So u dot v equals v dot u. The second one is when you create a dot product between a vector and itself, you get the magnitude of u squared. So that'll show up a little bit later. We'll get familiar with that. The third one is this, that if you take the 0 vector and multiply it by any vector, you get 0. Not multiply, sorry, dot. Four has two pieces. The first one is this, u dot, the sum of v plus w. And we have this sort of distribution property going on. So u dot v, remember not multiply, but the dot product, plus v dot w. Whenever you don't see the symbol, the dot symbol, we're multiplying, like in the dot product up here. And whenever you do see the symbol, that's the dot product. All right, so the second one for number 4 is u plus v. And we're going to create a dot product with w there. UW, University of Wisconsin. Okay. So cold right there right now. So 2 for the fourth property, and here's the fifth property. The fifth property, we have a scalar that's called cu. So it's being multiplied. That vector is being scaled up, so cu dot v equals u dot cv, which is also the same as c times u dot v. And like I said, c is just a scalar. It's a number. It's kind of dilating the vector, if you want to say it like that. So those are all the properties. As you practice the dot product, you'll get familiar with the properties, and you might have some exercises that specifically focus on those. So, like usual, pause me if you need more time. But now let's just take a look at an example of calculating the dot product, and then we're going to use that information to find the angle in between two vectors. So this is pretty basic. It's very direct because we're going to use it in application. Find the dot product of these two vectors, and we're just going to apply the dot product. Here we go. So we're going to take the first component of each vector and we're going to multiply them by each other. And we're going to add that to the second component of each vector being multiplied by each other. And that's all there is to it. We have negative 4 plus negative 6 equals negative 10. So a pretty simple formula to remember. Multiply the two and add them. So let's apply that to calculating the angle in between two vectors. So I love this. This is really neat. We could use trig by itself to do some things like this, but the function cosine theta is part of this whole definition here. All right, so here we go. This is the actual definition of the angle between two vectors. So if theta is the angle between some non-zero vectors, call them u and v, those are usually the two, then what we have is, it's a very formulaic approach at first approach, and maybe we'll dissect this later. So we have cosine of theta is equal to the dot product, aha, we're using this in application now, the dot product over the magnitudes of the two vectors being multiplied by each other. Cosine theta is the dot product of the two vectors divided by the product of the two magnitudes. Okay? So what that means to actually calculate theta, theta is cosine inverse of all that. So cosine inverse of u dot v over magnitude of u times magnitude of v. So that's the definition of angle between two vectors. And when we do these steps, we do cosine theta and we write this formula out and we calculate this. What I like to do is I like to calculate the dot product of u and v, the magnitudes of u and v separately, and then plug that into the formula. Simplify it maybe one step and then go right to the calculator in degree mode. Aha, degree mode. For now we're going to be in degree mode so that we have some practical answers that we can see and understand. Shall we apply it? Let's apply it. Find the angle between negative 2, 3, negative 4, 1, these two vectors. So let's call them u and v. So we're going to do three things, like I mentioned in the formula. We're going to calculate the dot product between the vectors. We're going to calculate the magnitude of each vector, so that's three things. And before we do all that, let's just get a sketch of what these vectors look like. So, because I know that u, negative 2, 3, is in quadrant 2, and v, negative 4, negative 1, is in quadrant 3, I'm just going to focus on sketching a graph that shows both of those quadrants. Royalty? And let's see here. I just need to go left 4 units and up 3 units. So each tick mark here is 1, and I will sketch u first. So just plotting that point. I'm starting from the origin, and I'm drawing an arrow at the end. So that's vector u. And now in blue, I'll sketch vector v, so negative 4, negative 1. I just plot the point and sketch that line segment, the directed arrow. So if I'm starting at the origin, like me actually moving, I'm ending at negative 4, negative 1. So we have those two vectors, and let's see here, oh, that's v. Okay, and then theta is just the angle in between the two vectors. So let's do that in orange. Theta is that angle. Now, just looking at that, I'm thinking, oh, that's got to be less than 90 degrees, because if it was 90 degrees, that green vector would be a little bit more vertical. In fact, it would probably be negative 1, 4, or something like that. Okay? So I'm just going to start that calculation process. I'm going to do u dot v, which is equal to negative 2 times negative 4. I probably should have just used the previous one. 3 times negative 1. So quick calculation, 8 minus 3 is 5. That's the dot product. And then magnitude of u, square root of the two components squared, so 4 plus 9 equals square root of 13. Magnitude of v, square root of the components squared, so 16 plus 1, square root of 17. So here's where we'll start to get our calculators handy to calculate this, because I'm going to just write down first what cosine theta is. So cosine theta is 5, which is the dot product, over root 13 times root 17. So that's the very definition of the angle between the two vectors, just plugging in the values that I found here. So 5, root 13, root 17. And if we're doing an actual problem, this is the work that would be shown, and we don't have to show this last step. So theta, therefore, is equal to cosine inverse of all of that, 5 over. And what I did, I just simplified that so I don't have to type as much. Well, I guess if I calculated that, I had to type more too. So I don't know. I could make some mistakes. 5 divided by root 221. It goes straight to the calculator. Mode, radian, and calculate that. I get 70.3 degrees. And that's a wrap for that question. So if you haven't done it, actually calculate that on your calculator. Second cosine of 5 over root 21, close those parentheses, press enter, and you will get an answer that has quite a bit more decimals than this. And we would likely round to the nearest whole number with something like that. Just one last thought for you. Thanks for sticking with me. And here it is. It's just a quick definition about orthogonality. If u dot v, if the dot product of u and v is equal to 0, then u and v are orthogonal. In other words, they meet at 90 degrees. And for you people, for any people who plays a tabletop game, you might come across the word orthogonal in that particular board game. Okay, so if you calculate that and equal to 0, then those vectors meet at a 90-degree angle. Thank you so much for watching. Next up in the video series is projection and hopefully a little bit on effective force. Thanks.